Welcome to The Explainer. Today, we're diving into a question that has literally jumped right out of science fiction and into the very real worlds of physics and Silicon Valley. Are we living inside a simulation?
So let's just kick things off with that provocative question, which has gone from a late-night philosophical debate to, well, a serious hypothesis for some pretty influential people.
You know, this isn't just some late-night dorm room thought experiment anymore. It's an idea that has totally captured the imagination of the tech world, and it's led to some pretty extraordinary claims.
Yeah, it's a totally wild idea. But look, before we can even begin to answer it, we've got to understand the bizarre but very real physics that inspired it in the first place. Okay, let's dive in.
This whole journey, it doesn't actually start with computer code. Nope. It starts with a really mind-bending idea from physics that's known as the holographic principle.
Think about one of those classic holograms, maybe on an old credit card. It's completely flat, right? A two-dimensional surface. But when the light hits it just right, boom, a full three-dimensional image pops out. What if the physics of our entire universe worked kind of like that?
And here is the absolutely crucial difference. With a normal object, if you break off a piece, the info for that piece is just gone. But with a hologram, the information is distributed, kind of smeared out across the whole surface. Every single piece of that 2D plate contains information about the entire 3D image. That single idea is key to everything that follows.
So, this led cosmologists to ask a pretty wild question. What if our three-dimensional universe works the same way? What if all the information that makes up you, me, and everything we see could actually be encoded on some distant two-dimensional boundary? To see if that was even possible, scientists had to look at the most extreme information storage devices in the entire cosmos.
To test this holographic idea, physicists turned their attention to black holes. Turns out, they're the ultimate masters of compressing and storing information.
I mean, think about it like this. If I start filling up a closet, its storage capacity is based on its volume, the 3D space inside. More volume, more stuff. Makes perfect sense, right? Well, black holes, they don't play by those rules.
Black holes are just profoundly counterintuitive. When you throw things into one, the maximum amount of information it can hold isn't proportional to its 3D volume. It's proportional to the 2D surface area of its event horizon. It's like finding out all the books in a giant library aren't stored on the shelves, but are somehow encoded in the paint on the library's walls. It's nuts.
And the scale we're talking about here is just staggering. Physicists figured out the space needed on that surface to store just one bit of information, a single yes or no. It's called the Planck area, the smallest possible patch of surface in the universe, and it measures just 10 to the minus 66 square centimeters. You can't even picture how small that is.
This is the holographic principle in action. The thinking goes, if a black hole can store information this way, maybe the entire universe can too. It suggests our 3D reality could just be a projection of information living on a 2D surface at the edge of the cosmos. But this radical idea actually points to something even deeper about reality itself.
All of these ideas we've been talking about, simulations, holograms, black holes, they all revolve around one fundamental thing: information. And as it turns out, information isn't just an abstract concept. It's deeply, physically real.
To get our heads around this, let's look at a famous thought experiment. Imagine a tiny, intelligent being, a demon, and it's guarding a door between two chambers of gas. It lets the fast, hot molecules pass to one side, and the slow, cold ones go to the other. The result? One side gets hot, the other gets cold, and you've basically created a perpetual motion machine, which violates the laws of physics. This seems to break one of the most fundamental laws in all of physics. And for decades, scientists were stumped. So what's the catch? Where's the flaw in the logic? Well, the answer isn't in what the demon is doing. It's in what the demon is thinking.
See, the catch is the demon's memory. To keep track of the molecules, it has to record information. But its memory is finite. Eventually, to keep working, it has to forget. It has to erase what it's seen. And here's the thing. Erasing information isn't free. It has a cost.
And this is the absolutely mind-blowing part. The tiny puff of heat that's generated by erasing just one bit of information, that energy cost perfectly cancels out the energy the demon gained. The cosmic books are balanced. The laws of physics are saved, all because information is physical. Erasing it has a real energy cost.
Okay, so let's bring all these incredible ideas back to where we started, the holographic universe and this whole simulation hypothesis. Now, while this is a powerful and fascinating idea, before we declare the universe is a hologram, we have to pump the brakes. It's really important to be precise about what we actually know versus what we just theorize.
So here's the deal. The holographic principle has only actually been proven to work for a specific model of a universe, one that has a different geometry than our own. It's an incredibly powerful theoretical tool for physicists, for sure, but it's not a literal description of our cosmos. Not yet, anyway.
That simple simulation theory? It's actually pretty weak when you think about it. It doesn't really solve any deep questions. It just pushes the problem back a step. Well, who created the simulators? But in exploring all the physics behind it, we've stumbled upon something way more profound.
What we've learned is that information is not abstract. It has a physical price and a physical place in our universe. Whether it's encoded on the surface of a black hole or being erased from a tiny demon's memory, it's a real quantity. The line between the stuff of reality and the bits that describe it is getting far, far blurrier than we ever imagined.
And that is the real takeaway here. It's a question that doesn't just ask if our reality is real, but it challenges us to redefine what real even means. If information is physical, what is reality actually made of? That question leaves us with a much deeper sense of wonder than any simple simulation ever could. Thanks for joining this explainer.